Good evening. I haven't done a video in a while, and the primary reason is that I've been getting my gear into these racks that I bought and relaying out the workshop. And so once I get it all done, I'll start back in on some of the videos. But wanted to give you a quick commentary about thinking through the problems that you've got. I just got this microwave converter, and this is basically a down converter, and it enables me to connect it to my 8902A measuring receiver here, and then feed in up to a 26.5 gigahertz signal, give it an external local oscillator, and then tell the 8902A what the local oscillator frequency was, and then it would actually read out the frequency that it was getting in, and I can do AM, FM power measurements and so on. And I'll do a little video using this, looking at the 8672A that I repaired in the previous video. And we might have a look at my 8673B as well, and some other componentry. Anyway, I was playing around with this, and I didn't have my second microwave source, so I only had the 8672A. But what I did have was one of these little TPI synthesizers, and it's actually a really good product. Very accurate. The guy that sells them on eBay does a fantastic job. They're actually really good, but they do have some limitations. And so what I was doing was using it as the local oscillator, and I was getting some weird readings, and I started sort of playing around and saying, well, let's take a look at the frequency. Now, what I'm going to do is I'm going to set this up and connect this to the 8902A, and we'll just see what frequencies we measure. So we'll get that in the next shot. Okay, so here you can see I have the unit connected, and it's shooting in 1 gigahertz signal into the measuring receiver. The measuring receiver is picking that up that fine. You know, I have it set to 0 dBm, and you know, at 1 gigahertz with this cable and things, I'm losing about uncalibrated 2 dB. Yeah, that's reasonable for me. And so I was like, that's great. You know, I can use this to do the local oscillator and so on. But then I started to play around, and I'll show you what happened. Let's take it and set 300 megahertz. And you see now the 8902A is going getting 300. All nice and good. Let's do 100 megahertz. And now notice how it's 1100 megahertz. And I was like, oh crap. You might have, I might have done a video on this, I sort of forget, but when I first got one of my 8902As, one of the issues with it was that I had a problem with the frequency doubler. And so it would read frequencies correctly up to a certain level, up to a certain frequency, and then it would start doing random sort of values. Now this is actually operating the other way. The other way it was fine up to about 640 megahertz, and then above that, when the doubler would kick in, it would start acting like a mixer. But in this case, it seems to be inverse. I was like, well, man, I wonder if that's the same problem. And so I tracked it down. I started poking around, and you know, I looked at this and I said, okay, well, I'm getting 100 megahertz. Am I really getting 100 out of this? And so now what I did is I took this and I funneled it into my microwave frequency counter. So let's take a quick look at that. So plugging it into my microwave frequency counter here, you can see that yes, I'm getting 99.99984 meg out of it. And I thought, well, you know, is it a power problem? And you know, I can also take a look at the power on this and say, no, it's still about 0 dBm, which is sort of what I'd expect. I'm like, I wonder what's going on. And I started thinking that it's going to be the 8092A. Then it occurred to me, let's take a look at it on the spectrum analyzer. And here I've plugged it into the spectrum analyzer, and you can see the signal that the spectrum that I'm getting out. And it's clearly got a lot of harmonics, and that was the thing that I'd forgotten. When I had used the TPI synthesizer before, I noticed that it had the harmonics. You can work around them by being careful with the signal that you're checking the peak and so on, and most of the time with the counters it'll work. But clearly this harmonics was creating an issue with the 8902A. And what I needed to do was to come back to the 8902A and tell it to get out of automatic mode, where it tries to find its peak that it feels most comfortable with, and tell it to actually use a particular frequency. So let's take a look at that. Alright, so here we go. We're connected to the unit now. So what I'm going to do is I'm actually just going to type in 100 megahertz and tell the unit to track on that 100 megahertz signal. And now if I go and change that signal a bit, so I changed it a little too much, but if you see I drop it down to 99, the unit can track it and hold onto that signal. If I go and look at RF power, you know, we're sitting at around that same power value. So now I'm actually isolated on the particular peak that I wanted to. So that's something that you need to be aware of. It may not be a problem with your equipment, it may be a problem with the signals that you're putting into it. That was the case in here, in that I was getting confused because my equipment was locking onto a different harmonic. And it wasn't until I looked at the signal on my spectrum analyzer that I remembered, yes, the harmonics there. So we'll have to wait until I get my the 8673B up and running to take a deeper look at the 11793A. Anyway, I hope you found that interesting as a little word of warning, and I look forward to posting a video shortly. Thanks. Catch you later. Bye.